Some natural phenomena. Nature has its own way of expressions. It expresses itself through various natural phenomena. For example, sunrise, sunset, rain, lightning, thunderstorms, earthquakes, cyclones, bursting of volcanoes, floods, etc. Thus, the natural way of occurring some happenings in nature are called natural phenomena. We have no control over these happenings, whether harmful or useful to us. Some natural phenomena like rain is beneficial to us. However, the happenings like earthquake, thunder, floods, etc. are harmful and we do not like them. They may cause huge loss to life and property. Lightning. The occurrence of a natural electrical discharge of very short duration and high voltage between a cloud and the ground or within a cloud accompanied by a thunder is called lightning. Lightning and thunderstorms occur simultaneously. A storm with thunder and lightning is also accompanied with heavy rain or hail. The natural phenomena have fascinated people for ages. Several people researched about the cause of lightning and its process. Benjamin Franklin discovered that there is an electrical discharge between clouds that produces a spark, and it is the electric spark between the clouds and the earth that appears as lightning. His famous kite experiment proved this fact. Electric charge. Electric charge is the intrinsic property of an atom that causes it to experience a force when placed in an electromagnetic field. There are two types of electric charges, positive and negative in an atom. Atoms are the building blocks of the universe. Whatever you see around you can be divided into smaller and smaller parts until you finally reach a part you cannot divide further. This building block is what we call an atom. Atoms are made of protons, neutrons, and electrons. Protons are positively charged, neutrons have no charge, and electrons are negatively charged. An atom has an equal number of electrons and protons, and it carries no charges. Hence, atom is electrically neutral. However, any disbalance in the number of protons and electrons creates an electric charge. The charge on the body is positive. If the number of protons exceeds the number of electrons, the body is negative. The proton and neutrons together form the nucleus of an atom as they are present in the center, while the electrons revolve around the nucleus in fixed orbits or shells. Static electricity. Static electricity refers to an imbalance between the electric charges in a body, especially the imbalance between the negative and the positive charges. One of the most common causes of static electricity is contact between the solid objects. The movement of protons is not possible, and the only movement of electric charge seen in static electricity is electrons. Electrons are held very loosely that they can be exchanged through the simple contact like rubbing. When two objects are rubbed together to create static electricity, one object gives up electrons and becomes more positively charged, while the other material collects electrons and becomes more negatively charged. We should keep in mind that the rules such as charges repel and unlike charges attract is applicable here. Consider an example in which we rub a plastic rod for a few minutes with a dry cloth. It is observed that the cloth becomes positively charged after rubbing. Method of electric charging. The process of supplying the electric charge or electrons to an object or losing the electric charge or electrons from an object is called charging. An uncharged object can be changed in different ways, that is, charging by friction, conduction, or induction. Charging by friction. When an object is rubbed over another object, the electrons get transferred from one object to another. This transfer of electrons takes place due to friction between the two objects. The object that transfers electron loses negative charge or electrons, and the object that accepts electrons gains negative charge or electrons. Hence, the object that gains extra electrons becomes negatively charged, and the object that loses electrons becomes positively charged. Thus, the two objects get charged by friction. The charge obtained on the two objects is called frictional charge. This method of charging an object is called electrification by friction. Charging by conduction. The process of charging the uncharged object by bringing it in contact with another charged object is called charging by conduction. A charged object has unequal number of negative electrons and positive charges, protons. Hence, when a charged object is brought in contact with the uncharged conductor, the electrons get transferred from charged object to the conductor. Charging by induction. We can also charge a body by bringing a charged body near it, without touching it. The charged body induces the same charge that it has on the uncharged body. This method of transfer of charge is called induction. Thus, the process of charging the uncharged object by bringing another charged object near it, but not by touching it, is called charging by induction. Transfer of electric charge. The transfer of charges is responsible for the static electricity in various objects. Static electricity is the main reason of lightning. We can transfer electric charge from a charged object to a neutral object through a metal conductor. A device called electroscope is used to detect and measure electric charge is based on this principle. An electroscope detects whether an object is charged or not, and also the type of charge on a body. It consists of a glass jar fitted with a cork lid and a metallic wire passing through it. There are two metallic strips at the bottom of the wire. The upper end of the wire is connected to a metal disc. When a positively charged body is brought in contact with the metal disc, the charge is transferred to the metal strips through the wire, and the strips diverge because both the strips acquire same charges and they repel. If the metal disc of the electroscope is touched with the hand, it loses its charge to the ground by the transfer of charge through the human body. This is called earthing. How does lightning occur? The formation of clouds involves friction between water droplets in the atmosphere. The friction charges the particles in the atmosphere. Among the positive and negative charges, the negative charges accumulate at the bottom of the cloud and the positive charges at the top. As the accumulation of the charge increases, the cloud will induce positive charges on the ground nearby. As the amount of charge increases, the negative charges on the cloud tend to make a path towards the ground, and it results in a narrow streak of electrical discharge, which we call lightning. Lightning conductors. It is a simple device which protects a building from being hit by lightning. The lightning conductor consists of a metal rod which spikes at the top and a copper plate attached at the lower end. The copper plate is buried deep in the earth. If lightning strikes, it flows to the earth through the metal rod without causing any damage to the building. Safety during lightning. Despite fixing lightning conductors, we sometimes hear of buildings catching fire due to lightning. This happens because of the high magnitude of electric current of lightning, often exceeding 100 million volts and 40,000 amperes. Lightning current divides itself to follow every conductive path to the ground. Even this divided current is enough to ignite a fire, blow apart bricks, stones or concrete, or injure people inside the building. Lightning can hit anyone in the wrong place at the wrong time. It can hit the same place many times too. Hence, we need to take some precautionary measures to protect ourselves from lightning. Do not stand under a tree. If the tree gets hit by lightning and catches fire, you can be harmed. Do not remain in an open place. Take shelter inside a building or a parked vehicle with all its doors and windows closed. The metallic frame of the vehicle will keep you safe by acting as a lightning conductor. But take care not to touch the metal to avoid getting a shock. If you are out in the open with no safe place around, squat down with your feet together and only let your feet touch the ground. This way, you will reduce the chances of letting electric current to pass from the ground to your body. Do not use electrical appliances when lightning strikes. Stay away from water. Do not take a shower because water is a good conductor of electric current. Do not go on the terrace or on the roof of any tall building. Lightning can strike telephone cords, electrical wires, and metal pipes. During a thunderstorm, contact with these should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Electrical appliances like computers, television, etc. should be unplugged. Electrical lights can remain on, they do not cause any harm. Earthquake. The sudden shaking of the earth, which lasts for a very short duration, is called earthquake. The crust of the earth is composed of several pieces of land mass called tectonic plates. The tectonic plates are in continuous motion. They keep on brushing against each other or striking each other. When a tectonic plate brushes against another or strikes another tectonic plate, it results in vibrations in the tectonic plates. These vibrations are experienced by us in the form of an earthquake. Structure of the earth. The earth has three main parts: the crust, mantle, and core. A brief about these parts of earth. Crust. It is the outermost solid shell of the earth. It is of non-uniform thickness and is thinner at the ocean floor. It is composed of a variety of rocks. Mantle. It lies just below the crust. It consists of semi-solid rocks, iron, magnesium, and calcium. It is divided into various layers based on the scientific study of earthquakes. Core. It is the innermost part of the earth and is divided into two sections. The outer core contains iron and nickel in molten state. The inner core is believed to be made of compressed iron and nickel in solid form. Seismic or fault zones. The boundaries of the tectonic plates are at high risk of earthquake. These boundaries are called seismic zones or fault zones. In India, Kashmir, western and central Himalayas, the whole of the northeast, Run of Kutch, Rajasthan, and Indo-Gangetic plains are at high risk of getting hit by an earthquake. Some parts of the Deccan Plateau are under the seismic zone. Measuring intensity of earthquakes. All earthquakes are not of the same magnitude. The magnitude depends on the amount of energy released and can be evaluated by the size of the seismic waves. The instrument used to measure seismic waves is called a seismograph. It consists of a pendulum bob or a vibrating rod suspended with base of the seismograph. The instrument is fixed to the ground. When the earth shakes, the base also shakes, and the tip of the pen records this movement on the graph paper. The record of the seismograph on the graph paper is called seismogram. Richter Scale. The Richter Scale was developed in 1935 by Charles Richter and Beno Gutenberg of California Institute of Technology. This is a logarithm scale which shows the intensity of an earthquake. The intensity of an earthquake is measured on a scale of 0 to 10. But earthquakes of more than 9 Richter have never been reported. The magnitude of earthquake increases by 100 times when we move 1 point on the Richter scale. This means that an earthquake measuring 5 on Richter scales is 100 times more powerful than one measuring 4 on Richter scale. Earthquakes are classified on the basis of the readings on the scale. Richter magnitude. Earthquake effects. 0 to 2, not felt by people. 2 to 3, felt a little. 3 to 4, ceiling lights swing. 4 to 5, walls crack. 5 to 6, furniture moves. 6 to 7, some buildings collapse. 7 to 8, many buildings destroyed. 8 and up, total destruction of buildings, bridges and roads. Destruction caused by earthquakes. Earthquakes of high intensity cause massive destruction to life and property. Some earthquake hazards are: earthquakes can cause great damage to man-made structures like buildings, roads, rails, bridges, etc. These can change the whole landscape of a place by deforming the ground surface. High-intensity earthquakes can uproot electric poles, telephone wires, and trees. Strong vibrations caused by an earthquake can burst gas cylinders and short-circuit electric wires, causing a fire in houses, mines, factories. It can also cause forest fires. In mountainous regions, the tremors caused by earthquakes can lead to landslides. This causes damage to human settlements and the transport system. When an earthquake occurs under the ocean, large waves called tsunami are generated. When a tsunami hits the shore, it causes a lot of destruction. Protection against earthquake. It is not in our control to prevent an earthquake, but we can take some necessary precautions to minimize the damage caused by it. There are some ways by which we can protect our property and ourselves from destruction. While constructing a building, consult a qualified architect and civil engineer for tips on how to minimize the effect of an earthquake on the building. Do not construct buildings on landfills or reclaimed areas, as they may be weak to support in case of an earthquake. Use light construction material like timber or mud in highly seismic areas. Make the roof as light as possible. Fix bookcases, cabinets, cupboards and shelves securely to the walls so that they do not fall easily. Secure firmly the objects like ceiling fans, air conditioners, air coolers, water heaters, etc. so that they do not fall during an earthquake. Keep firefighting equipment handy, as some buildings may catch fire due to an earthquake. Repair any cracks in the walls or ceilings. Personal safety during an earthquake. Take shelter under a heavy table or a cot and stay there till the shaking stops. Keep away from tall and heavy objects that may fall on you. If you are in bed, do not get up. Protect your head with a pillow. Avoid using a lift. Leave the building you are in and move to an open area, but take care to be away from electric poles, signboards, trees, or tall structures that could fall down. Stay inside a car or a bus if you are traveling. Ensure the vehicle is not near an electric pole or a tall building.